Welcome back to ACER Explained. I'm going through the section 3 bit of the ACER Practice Question booklet, and in this video, I'm going to be going through Unit 6. So Unit 6 has 2 questions. As always, I'm going to be talking about the prereq knowledge, reasoning skills, and some of the bootcamp resources that you can use as well. So in this unit, we're given some information about Antarctic fishes. So we're looking at freezing points and how the concentrations of different ions can influence that freezing point. And so we're given this formula here that I will write down. So we have the change or the decrease in the freezing point, that's what this represents, is equal to the molar freezing point depression constant. So that's a constant for any particular ion or molecule. So we have Kf, so that's the freezing constant, okay, multiplied by m, which is the number of moles of the solution, okay? Technically, we're also given the information that says that because it's a physical property of a solution, well, it's a physical property of a solution that depends on the concentration of particles rather than the moles themselves. So it says particles, not on their chemical identity, it's depending on the concentration of particles. So that's very important for this next question here, for question 14, because question 14 is asking us about benzoic acid. So benzoic acid molecules form dimers. So that's kind of the important information that I've highlighted here, okay? And they've given a bit of an equation that demonstrates this. But it's saying that what would the actual freezing point depression be compared to the theoretical value? So the theoretical value, we have to think that it's referring to the benzoic acid concentration. And so we're given that to be 0.01 mole solution. So that's 0.01 moles per liter of benzoic acid. But benzoic acid, it forms a dimer. So say you have 1, 2, 3, 4 benzoic acid or moles of benzoic acid. They will form dimers such that you only have 2 particles. So from 4, you went for 2, right? So the dimerization halved the number of particles, okay? So looking at this equation here, right, M has changed now. It changes from 4 to 2. So the theoretical value would be this equals to Kf, which is constant for benzoic acid. So, we're not changing the type of solution here. We're just changing the fact that the physical property of it. So this stays the same, so we can pretty much ignore that. And then times, originally the theoretical would be 0.01 because that's the moles, right? However, because of this dimerization, the number of particles that you have to have an impact on freezing point halves. So you have Kf times 0.005. It doesn't really matter what these two values are. We know that if this halves, then this will also halve because they're directly proportional to each other. Okay, so if you times this by half, then this side will also half. So that means that the freezing point depression is going to be half of the theoretical value because of this dimerization. Okay, and that's option A. And this is just the same thing that we said before, put into different words. So if you want to pause this and take a look, then it's here for you. This unit required no previous knowledge. The equation was provided to you. and so was the relevant information, but you just had to pick out the relevant information and ignore the rest because there was a lot of other information that you didn't actually need. So this would require the skill of you being able to scan the stimulus initially just to know where the information is, and then read through the question and then go back and find that important information and ignore the rest of it. You also needed to know about proportionality. So if something's directly proportional, if it halves on one side, for example, it will halve on the other side. If it multiplies by 2 on one side, it will multiply by 2 on the other side. Whereas inversely proportional would have the inverse effects. And so some bootcamp resources for this include the reasoning skills course, the acceleration class on calculations and formulae, and also the bridging course on moles and calculations. This is another calculations question. You just need the equation that was provided to you. So I'm going to draw out the equation again. So we have the decrease in the freezing point is equal to the mole freezing point depression constant multiplied by the number of moles. Okay, so we're given quite a lot of information here. So we're given our decrease in freezing point is 0.4 degrees Celsius. So I'm going to plug that in here, 0.4. And we know this because it says that the electrolyte solution has a freezing point that's 0.4 degrees below pure water. So that's kind of like the difference between whether you had normal water or pure water, sorry, versus the effect that adding this solute would have. So that means that the decrease in the freezing point from the normal is 0.4, okay? Then we have the mole freezing depression constant for water, and that's in per mole per kilogram. So we have 1,000 grams of water, but either way, we have 1.86, okay? Oh, apologies. I'm just gonna get rid of that there. Put that on the wrong side. So that is equal to 1.86 multiplied by m. Okay, so pretty straightforward. All you have to do is solve, first of all, for moles. So you can start off by, well, I love working with full numbers, not decimals, so I'm going to just make this into a 4. I'm going to multiply it by 10 on this side and multiply it by 10 on this side. So I can just get 4 equals to 18.6 times m, so just easier numbers to work with. Then I have 4 over 18.6 equals to m. Okay, so that's the number of moles, all right? I'm going to put moles as this because it can get quite confusing. Then another thing you need to know here is your n equals to m over m chemistry or moles equation. So your number of moles is equal to the mass divided by the molar mass. So the question is asking for the molecular weight, which is the molar mass. So we're trying to find what that is. Okay, so I'm going to rearrange the equation first to make life easier. So what I will do is I will divide both sides by n. So I'm going to get, so n divided by n is 1, okay? M, and then dividing it by n. So bringing n down to the bottom here. And then I'm going to multiply both sides by molar mass. So multiplying this side by molar mass will cancel it out because I'll have and it'll cancel. And then multiplying molar mass by 1 will just give me molar mass. So I'll get, okay, so mass over moles. So the mass is something that we're given. We're given that the electrolyte solute mass is 40 grams. So we have m is equal to 40 over, then we have our 4 over 8.6. Okay, and then we can solve that by going 40 divided by 4 over 18.6 is equal to 40 multiplied by 18.6 over 4. And so we can see here we have some simplification that we can do. So divided by 4, divided by 4. And so we have 10 times 18.6 over 1. So we have 186. And that's how I would do the calculations in a GAMSAT scenario without a calculator there. And here's the working out in a different format if you want to pause and take a look as well. So for this question, you need to know the molar mass formula, which is this one here. This is a really important formula, so something that is worth, practicing quite a lot of and just having it ingrained into your memory. And the reasoning skills here are basically just your calculation skills and working with fractions and trying not to get bogged down into decimals, because otherwise you wouldn't have been able to quickly come up with the answer and you would have really struggled without a calculator. So Bootcamp resources that you can use here are the Reasoning Skills course, the Acceleration class on calculations and formulae, as well as the Bridging course on moles and calculations, where you can learn a little bit more about this one here. So that brings us to the end of Unit 6. Thank you for watching, and as usual, like, share, and subscribe for some more GAMSAT help. We really appreciate the feedback. And we have our Instagram at ThankFlipGamSat, as well as our podcast, ThankFlipGamSat, Nurses Doing GAMSAT, if you want to hear more from us. See you in the next one.